welcome to the 7th video for map assignment number 4. Let's analyze. Let's look at our traces before we do some time alignment. Let's open up our stored main trace. And we've got a live subtrace, and we'll look at them together. You can definitely see that they are not in phase with each other. Let's zoom in over here on the impulse response. And you can see the mains definitely show up earlier than the subs. And if you remember from our alignment before, we really kind of needed the mains in this vicinity. So the mains are pretty early. This directly aligns with what we're seeing here in the model view. If we look top down here, you can see that the measurement mic, and I will hide the layers, right? It doesn't matter. The measurement mic, if I select it, it's over there. It's a lot closer to the mains than it is the subs. So it would make sense that the mains show up earlier. So we definitely have a situation where we need to drag the mains. We need to make the mains later so that they can arrive at the same time the subs happen. So this is a pretty simple alignment. It's not as complicated as the one before. There's not much debate here regarding who you're going to delay. So in the measurement view, I think we're going to need to see the mains live and the subs stored. So I'm going to hide the mains stored trace and show the subs stored trace. And we're going to need to go to our processor and turn on the mains, not the stored subs, because we're going to be messing with the delay of the mains. So back to our measurement view, it should automatically predict, and you can see exactly what we saw a moment ago. So we want to walk this guy over there, and you can almost tell in milliseconds what needs to happen. You're going to move this transient somewhere in the vicinity of here. So you could start by putting in a number higher than 1 millisecond is what I'm getting at here. So let's select our processor and go to express settings, and I'm going to automatically put in 10 milliseconds because 10 milliseconds is going to move my transient into this area and hopefully get that closer to where I want to go. So I'll type in 10 milliseconds on the mains, and boom, and it's really potentially better, but until we zoom in and really see our low frequencies, you can see I'm pretty close. Our target frequency is 80 hertz, right? It's want to align your eyes. You're heading for that area right there. We're not quite there. Let's see if I overshot it. I don't think I overshot it, but let's add another millisecond. Getting closer. 12 milliseconds. Oh, we're really close. 13 milliseconds. I would say that's right on. Let's go past it. Yeah. So again, it might be 13.5, but I'll just go with 13 because it's a whole number. And you can see that the transient lined up again, kind of the same way it did earlier when we were doing our center alignment. And so you can kind of judge once again that for the subs, this is where 80 hertz happens in its transient, and this is a higher frequency for the subs. So we're good. Higher frequency being, you can actually tell here, it's probably around 200. That's what that is. But that's irrelevant information for the moment. So I believe we've got these two aligned. Do you want to see it? Should we see what's happening? Let's go over to our processor and make sure we have it. We've got to take this 13 milliseconds and distribute it everywhere before we forget. So that 13 milliseconds is going to be across the left and right arrays. And at the moment, our left array is consolidated on this first drive line, but our right array is still split out over outputs 7 through 12. We'll turn on our mains, which have been turned down by 1.5 dB to give it equal level. Let's go over to model view, and let's go into viewport 1, deselect that microphone. I'm going to drag it over, and let's predict at 80 hertz. Meanwhile, while it's doing that, I want to go over to the instructions, make sure I didn't do anything wrong. Well, I'm pretty sure that, look, it even said 13 milliseconds when I did this before. It was the same amount of delay. So let's take over here, I'll take a coffee break. maybe a latte, steamed milk. Oh, so there's our alignment. How does it look to you? Well, you're going to want to take a screenshot of this, and you're going to want to compare it to the previous screenshot. And I've done this here in the instructions already. Here is what we're seeing there. It looks pretty much this. It is the same. You're going to want to name it map4.left alignment underscore last name first name. This is your screenshot. Save your map file and compare your versions. Now, mine are different. You might get a different alignment, but this is the unaligned. This is the aligned to center, and this is the aligned to left. And if you look closely, there's actually, which one do you like better? I mean, this is for you, for your drawing, which one do you like better? For my eyes, I actually like the unaligned because there's actually less level variance across the whole thing than there is on the left aligned or the center aligned, which really begs the question of what is going on with the unaligned. And I'm judging from these little really dark spots in the unaligned image that's actually the position of alignment, because unaligned is aligned somewhere. There is always an acoustic crossover, an area of equal level, and potentially, in this case, equal level and equal time, that is in the venue. And it's probably those two dots and maybe that one dot. And so that would probably be the place that it is. So the unaligned is actually superior in this particular case to either one that we did today. So why do we do it? I don't know. That debate is better left for class and discussion and that sort of stuff. But you do want to know this activity and you want to know how to timeline. So lastly, submission requirements. We need to make sure we restore our processor. Our speaker systems to the way they originally were laid out. I'm talking about in terms of output drive, where we had earlier put our left boxes all in 1 and 2. So let's disperse them how I done them earlier. Yours is probably different because you did this on your own in the assignment last week, but for the previous map assignment. But I'm setting all these drive lines to go back to where they're appropriately supposed to go. And not left box 5, but left bottom box. There we go. We should probably get a similar prediction here. While we're predicting, to double check that that is correct, let's go over and look in the instructions. Confirm that your overall map file is saved named map4 underscore left aligned underscore your last name underscore your first name. Of course, you have 2 map files now. Here's the list of what you're turning in. You have the center aligned map file, the left aligned map file, and 4 screenshots. Cardioid subs, system no alignment, center alignment, and left alignment. Stick all these in a folder, compress it into a zip folder, name it map4 last name first name, and upload that to Canvas. Let's check over here to make sure this looked the same, and that looks exactly how we want it. So good for you, and we'll see each other soon on the map.tv channel. Bye-bye.